the class. So we have 5 exponent x over 5 equals 100. Okay, so our equation becomes 5 exponent x equals 5 times 10. All right, so we are going to have 5 exponent x equals 5 exponent 1. 5 is the same as 5 exponent 1. Okay, now 10 can be written as 5 times 2. So this has an exponent of 1. All right, so you're going to apply the first law of indices here. Okay, so if you have a exponent m multiplying a exponent c, this gives us a exponent m plus c. Now in a case where the exponents are the same, okay, so in this situation we are using m, so we are going to have a exponent m plus m, and that gives us a exponent 2m. Okay, so our equation becomes 5 exponent x equals 5 exponent 1 plus 1 times 2. So we are going to have 5 exponent x equals 5 squared times 2. Alright, so let's divide here by 5 exponent 2, here by 5 exponent 2. So this cancels this. So we are left with 5 exponent x over 5 squared equals, okay, equals 2. Now let's apply the quotient rule. So if you have a exponent m over a exponent c, this gives us a exponent m minus c. So our equation becomes 5 exponent x minus 2 equals, okay, equals 2. Now the base here and the base here are not the same. So because of that, we are going to apply logarithms. So we say log 5 exponent x minus 2 equals log 2. All right, now let's apply the logarithm definition here. Okay, logarithm definition. So it states that log a exponent n base b should give us n log a base b. So our equation becomes x minus 2 times log 5 equals log 2. All right, so we're going to have x minus 2 times log 5 equals log 2. All right, now let's divide here by log 5, divide here by log 5. So this cancels this. So we are left with x minus 2 equals log 2 over log 5. All right, now let's apply the change of base concept or the change of base formula here. So we say log a over log b should give us log a base b. So our equation becomes x minus 2 equals, okay, equals log 2 base 5. So this will give us x equals log 2 base 5 plus 2. All right.